Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem and, all the good stuff. It is Memorial Monday here in New York City. That's all I have to say. Hope if you're observing it, I hope you're enjoying it or having a good weekend. Yeah. I don't know what I'm doing. I'm just gonna focus on this farm. I'm really tired. I went to the gym for too many hours and it was raining and I need to take a nap. Also, I think I've been training too hard lately, so I think I just need to kind of have a week off of training. But yeah, let's let's take a look at today's problem. Trouble 8, get Eco substrings within budget. You're given two string s and t of the same length and integer max cost. You want to change s to t. Changing the ith character of s to the ith character of t costs the absolute value of s of I t. Okay. Return the maximum length of a substring of xs that can be changed to be the same as the corresponding substring of t with a cost less than or equal to max cost. If there is no substring from s that can be changed to return 0. Okay, so I mean, this is just going to be max length. The idea is going to be sliding window, but the way that I think about it is going to be something more about contribution, right? Because another way to think about it, if you think about it in contribution terms, is that for each character, you can actually binary search as well, right? And the reason why you can binary search is that the function is going to be monotonically increasing if you add characters, right? For example, if you have this example 1, right, something like this, then you could binary search. Okay, if we start a substring with with B, how many characters can we convert with the max cost of 3? And you do a binary search on that, and so forth. And of course, that's going to be n log n, which given n is equal to 10 to the 5th, it should be good enough. But like I said, you can also use sliding windows based on the greedy portion of it, which is also based on the monotonicity of this function, right? The same reason that you can binary search is because the cost function, if you want to call it that, is just longer, monotonically increasing when you add more characters, right? But by the same token, it also monotonically decreases when you lower or when you remove characters, except for now you can remove it from the front instead. And because of these two properties kind of working together or maybe against each other, depending on how you want to say it, you're able to use something called a sliding window. Because then now, when you're trying to max, because another way to think about a sliding window is that as you slide the right side, instead of binary searching the left side, so it's kind of the opposite of what I did with the because here I said you can, for each character, you can just binary search, for this character, go to the right as far as you can. But another opposite way is that you can, for example, C is the last character in your substring. How many things can you go back to the left, right? And of course, you can binary search for that as well. But you can also monotonically decrease it, because then now this reaches the new upper bound of this character, the length, and also all characters in the future, right? Because if you add characters in the future, the cost will only go up. And because the cost only goes up, there's no way that you can add stuff to the left. So this idea of contribution, I think, comes into play in a lot of different places. And that's why I kind of try to teach it this way now. I know that sliding window is kind of like a very specific version of it. But I think once you have this understanding, you're able to solve harder versions of maybe sliding window, but some also problems that are kind of sliding window, but a little bit differently. Okay, so yeah, so then now we go, sliding window is that right is good for right in range of n, right? They're the same length, right? It should be, but with Leetcode, I guess you never know. So then you have a best. This is the longest length, and then the current is equal to current cost, right? And what does current cost mean? Is current cost of the window between left and right inclusive. Kind of. It's not quite true at the beginning, but it will be true at some point in the invariant. And here we go, okay. So then now current we added to the cost of adding one more character, which is of index on the right. And of course that is just the absolute value of s sub right minus t sub right? Something like this. Of course you want the ordinal. I believe ordinal in Python is not signed. Oh, sorry, it is signed. Because if it's not, then we have to kind of do some funky things. Not that funky, just a little bit funky. But yeah. So then now this includes. Now current include, and I want to add these comments also. I want to add these comments just for the viewers at home to kind of think about the invariance each step of the way. And this is that now current includes left and right inclusively, right? The includes is the sum of the cost include, yeah. And I want to say, just point it out that way because if you're in an interview or something, these comments probably are not useful, and maybe even, you know, like, why are you writing these comments kind of thing. But I just want to point it out, right? So then now if current is greater than max cost, then we have to shrink it a little bit by shrinking on the left side. And again, I think this is the reason why I kind of bring up contribution instead of just focusing on sliding window is because the more that I've been doing these problems, and you see my evolution over the last couple of years, the more that I've done these problems, the more it kind of reminds me of how I explain monotonically in what sometimes is called mono stacks or mono queues, right? It's just this idea of invariant, right? And the idea about mono stacks in a lot of cases is that you remove answers that are no longer could be possible future answers. And here, the left, everything left of the left cannot be a possible answer anymore. For the right isn't here because it just cannot go that, you know, because if you add more characters, it can only increase the cost, and you want to keep the cost under the max cost, right? Anyway, so yeah, so then now we do and one thing that you can also do in this one is just like pre-calculate all the costs. It doesn't, I mean, you know, I think that's a little bit, I don't know, makes this a little bit more cleaner, maybe a little bit more template-y, but I don't know. There's a very slight variation. It's not a big deal, right? And then now current is still the sum of all these stuff, but the additional variant is that current is max cost, right? So left, the substring from left to right is a possible answer. And of course, there is something that I want to point out a little bit as well, which I don't normally because I think I take it for granted. But some days I just like to be more for, not all the time, because sometimes I just forget. I have a very bad memory. I'm getting old. I'm sorry. And I'm doing these live, as you know. But the answer is that the substring from left to right is a possible answer, of course. So you would do something like max is equal to, or best is equal to max of this, or, you know, right minus left plus 1 for the number of count, and you're done. But the other thing that I want to point out is that the substring of these things are also answers. It's just that they're not the best possible answers, so we don't really consider them, right? For example, yeah, it's just that we don't consider them because they cannot be possible answers. And the reason why this is at least of note, it's not that important for this particular problem, but it is noteworthy because in certain problems, you do have to consider the stuff that the other substrings in a way, especially if you have to do counts or something like this, you have to make sure that you keep the count of them as well because they're asking a different problem, right? But for this one substring, you know, you're just trying to get the longest substring, so it doesn't matter. And what I mean for this is that, for example, let's just say in a very lazy example, let's say you have all A's and you're converting them all A's. So then obviously from if your left is going to be, I'm going to use L for left, if this is your left and this is your right, then obviously this is your best answer. But and as we move from here to one to the right, this is your best answer. But keeping in mind that all the other middle stuff is our possible answers. Like if we have a pointer here to here, like this chunk, this chunk is also a possible answer, and this chunk is also a possible answer, and so forth, right? So then now when we, in different variations of the problems, and maybe we have to count stuff or something like this, and you have to play around with the idea of the degree of freedom. That's what I mean by degree of freedom often, is that you have these in-between things that you can choose. It's just that for this particular problem, because you're trying to get the max, obviously the max is like anything smaller than even just this, it's going to be less than the max. And that's just a consideration for other problems. But yeah, that's all I have for today. Unless it's wrong, then I will have to do a little bit more. Don't I have premium? Why do they say this? But yeah, apparently I got it wrong. But it was 2019. That was a long time ago. Oh, I did it with a heap, huh? I don't know. What craziness is this? Instead, I did it with, yeah, okay. But yeah, as you can also see though, this was 5 years ago almost. I was definitely less, because that was when I was just starting out on YouTube. So some of the videos are like, like I'm still trying to find out how to teach certain things in a, a tighter way, if you will. But yeah, this is gonna be linear time, constant space, linear time from this, and technically this. Well, the constant space I think is obvious, so I'll say that first. But the why this is linear is even though there's a while loop, a weird looking while loop inside a for loop, is that, well, this is for loop, so this is linear, that's clear. But here, keeping in mind that the left can only increment n times, so that means that this while loop in total, or the entire lifespan of the algorithm, it's going to be at most O of n, right? Because left can only increment n times. And there's an other implicit thing that I didn't write, but and the reason I didn't write it is because it is also an invariant, which is that when left is equal to right, when left is equal to right plus 1, that means that the current cost is going to be 0, right? Because you subtracted everything. So current cost will always be 0, and 0 will always be less, not equal to 0. So this will always be true at some point. And so, yeah. And so this is the reason why. That this will always terminate, and it will only increment n times. Yeah, that's all I have for this one. Let me know what you think. I'm going to do another problem after this, but stay good, stay healthy, do good mental health. Hit all the buttons, hit the like button, hit the subscribe button. Yeah, have a good rest of the weekend. I'll see y'all later and take care. Bye-bye.